My name is Emma Doring, and this is my Physics 2211 Lab 5. I chose to do it on conservation of momentum and kinetic energy in Newton's cradle. Here's a table of contents. The purpose of this lab was to model the conservation of linear momentum in collisions as well as the conservation of kinetic energy in elastic collisions using Newton's cradle. So the models and fundamental principles, the models I used were GlowScript and Newton's cradle, and then the formulas I used were conservation of momentum formula, conservation of kinetic energy formula, and kinetic energy formula. And then the conservation of momentum formula was used to ensure that the final momentum of the system was equal to the initial momentum of the system. And then the momentum formula itself was used to calculate the individual momentums of each ball. The conservation of kinetic energy formula was used to ensure that the initial and final kinetic energies of the system were equal, proving that this was an elastic collision, and then the kinetic energy formula was used to find the individual kinetic energies of each ball. A preview of my results: after running the code, I found that the initial momentum of the first ball was equal to the final momentum of the last ball, and then same with the kinetic energy. And on the right is just a visual of a Newton's cradle in motion. So you can see the ball on the left is swinging towards the rest of them, and then it only causes the ball on the far right to move. The initial conditions: the mass of each ball was 100 grams, the initial velocity of the first ball was 2 meters per second in the x direction, and then the initial velocity of the last ball was 0 meters per second in the x direction. And then the radius was 0.5 meters for each ball. The time was 0 seconds initially, and then the change in time was 0.5 seconds. Details of my experiment: the system was Newton's cradle, the surroundings was Earth. Basically, I watched a video of someone pulling the first ball of Newton's cradle back and releasing it so that it hit the rest and caused motion of the last ball. I observed this collision between the first two balls, created a code in GlowScript that modeled the collision. I wrote the code for the two balls, wrote the initial conditions, solved for initial momentum and kinetic energy, created the collision and updated the positions and velocities of the balls, printed the final momentum and kinetic energy, and then plugged them into the conservation of momentum and kinetic energy formulas to check for an elastic collision. And then here's just a video of a Newton's cradle. My details of coding: so I think I already went through this for the most part, but basically I just set the initial velocities of the two balls on each end and then calculated the initial momentum and kinetic energy of the balls. I printed both of these and created the collision in the while loop, and then I updated the positions of each ball and found the change in distance. I included an if statement to check for collision based on whether the distance was less than 2r, and then if the collision did happen, I switched the velocities of the balls to find their final velocities and printed the final momentum and kinetic energy. So my final results: the initial and final kinetic energy of the Newton's cradle system was 200 grams times meter squared per second squared, and then the initial and final momentum was 200 grams times meters per second squared in the x direction. Basically, this all means that both kinetic energy and momentum were conserved, and it was an elastic collision. And then this matches the lack of deformation in the balls that I observed when I was watching the video of someone using Newton's cradle. On the bottom is an image of the output of my code, and then an image of me calculating the change in momentum and the change in kinetic energy. So some possible sources of error in this lab: I could have measured the mass of a ball from Newton's cradle incorrectly, and then I could have had coding errors, and I could have measured an incorrect radius of the ball on Newton's cradle. Additional questions: so what would happen if you initially drew back and released two balls on the cradle instead of one? Basically, the initial collision would cause two balls to move on the other end instead of just one ball, and this behavior would still model conservation of momentum and kinetic energy. It would just be a different amount of balls moving on the other end. And then what would happen if the balls were not aligned perfectly? Kinetic energy would not be perfectly conserved, and then momentum would occur in multiple directions, and this could even cause rotational kinetic energy, because if the balls don't hit each other perfectly head-on, they may be caused to spin and move in different directions. That's all. Thank you for watching.